Namaste one and all. So today we'll be studying the concept called as null point. So what is meant by null point? It is a point in a space where another charge when kept experiences no force. So here there is a charge q1 and there is another charge q2 and we need to place the charge q3 at such a position that it doesn't experience any force due to these two charges. That a position where it doesn't experience any force is called as null point. So in order to find this position, we are having two cases. So let us consider the first case, which is called as like charges. So here one charge is of plus q and the other charge is multiple of this charge. It is given as n into q, and these two charges are separated by a distance of d, and this value n should always be greater than 1. So as I said, it should be like charges. So either it can be plus plus or it can be minus minus. The same rule applies for the negative charge, which is applied for positive charge also. So the null point is always inside the line joining the 2-point charges or between the 2-point charges. So when they are like charges, if I try to bring another charge, I can place this charge between these 2-point charges, or I can also tell that it is between the line joining the 2-point charges. So that is, the charge should be placed between these two charges whenever both of them are like charges. But at what distance? It is at a distance of x from the smaller charge. Out of these two charges, as you know, this is smaller charge and this is n times of this charge. So the distance is always from the smaller charge. It is at a distance of d divided by square root of n plus 1, where n is the number of times multiplied by this charge, and d is the distance between these two charges. So at a distance x is equal to d divided by square root of n plus 1, we need to place another charge where it will be experiencing no force. This point is called as null point. The same thing applies for negative charges also. It is at a distance of x from the smallest charge at a distance of d divided by square root of n plus 1. So now let us consider an example to look at this. So this is charge q and this is 4 times of this charge q, and there is a separation of distance which is given by d. So here n into q is equal to 4q. So the value of n is equal to 4. So at the distance of d. So where would be the position? At a distance x, which is equal to d divided by square root of n. The value of n is 4. Square root of 4 plus 1 from the small charge. So this would be d divided by square root of 4 is 2. 2 plus 1 is 3. D by 3. So at a distance of d by 3 from the smaller charge, we need to place the charge. So this is the position of the null point. If you are asked to find the distance from the biggest charge, what you can do is take the total distance between the two charges, subtract this distance, that gives you the distance from the large charge. It is nothing but d minus d by 3, so that will be 2d by 3. So this is the distance from the biggest charge. I hope you understood this. Now let us consider the second case, unlike charges, where one charge is q, that is plus q, and the other charge is multiple of this charge but is negative, minus 4q. In this case, again the distance is at a distance of x is equal to d divided by square root of n minus 1 from the small charge, but the position of this charge should always lie not in between the charge but outside the line joining the 2-point charge. That is, it should lie towards the left of the small charge, or what can I say, it should never lie in between the 2-point charges. It will be lying outside the line joining the 2-point charges at a distance of how much? X is equal to d divided by square root of n minus 1, again from where? The small charge. It should always away from the small charge at a distance of d divided by square root of n minus 1. So here is the position where we need to keep the other charge so that it experiences no force. We call this as the null point. So in case of like charges, it was d divided by square root of n plus 1. In case of unlike charges, it is d divided by square root of n minus 1. Now let's consider the example. So one is 2q and the other is minus 7q, and the distance between them is d. So first thing is I need to make sure that one charge should be multiple of other charge. So what I do is I divide this by 2 so that I make this as q and the other as minus 7 by 2 q, because the other charge should be multiple times of this charge. So here n is 7 by 2. Don't consider the negative sign. We need to take only the magnitude. So it is 7 by 2. So here the distance x is what? It should be divided by square root of n minus 1 from the small charge. Out of these two charges, which is the smallest charge? This is the smallest charge. And the distance of d divided by n is 7 by 2 minus 1. And the distance of d divided by square root of 7 by 2 minus 1. So we need to consider the null point position. So instead of dividing 2q by 2, I could have also divided it by 7, so that this becomes 7 by 7, this becomes q, 7q by 7 is q, and when I do divide this 2 by 7, that turns out to be 0.28. If you look over here, if I divide it by 7, this becomes what? Q, and this becomes 2 by 7, which is 0.28. So in the first slide itself, I said that the value of n should always be greater than 1. So when you divide 2 by 7, the value is 0.28, which is less than 1. So this is not allowed. Dividing this number by 7 is not allowed, because you are getting the value of n as how much? 0.28, which is less than 1. Whereas if we divide it by 2, both the sides by 2, this, when you divide this by 2, this becomes q, which is given, and when you divide 7 by 2, this is 3.5. So it is 3.5, which is greater than 1. So this is allowed, because 1 is q and the other one is multiple of q, that is n, which is greater than 1, 3.5. So you need to remember this whenever you are trying to make one charge as the multiple of other charge. I hope you have understood this concept. So let us. So now let us look at the simulation version of the null point, which I explained. So first let us consider point charge A. So here point charge A is of 10 microcoulomb. So this is of 10 microcoulomb. And point charge C is of 100 microcoulomb. If you look over here, this is of 100 microcoulomb. So now what I am trying to do is, I am trying to bring another charge and trying to find the null point. Null point is the point where it experiences no force. So if you look over here, all over here it is experiencing some force. There has to be some place where it experiences no force. Okay. So if you look over, if I keep it here, so there is an arrowhead pointing outwards. So this indicates that it's experiencing force, and the arrowhead is outside because it is experiencing repulsive force. Both of them are positive charges, so they experience what? Repulsive force. So it is experiencing what? Repulsive force over here. So I need to find a place where it experiences no force. So as I already explained, so that null point is present at a distance for both of. First thing is, you need to understand both of them are like charges. Both of them are like charges. In that case, it is at a distance of x is equal to d divided by square root of n plus 1 from the smallest charge. From the smallest charge. So d is the distance between these two charges. So this is your d. So what is the d? 2, 4, 6. So the value of d is equal to 6. Now both of them has to be made in such a way that this should be, one should be q and the other should be n into q. So this is 10 microcoulomb and this is 100 microcoulomb. So what can I do is I can divide this by 10. So this is 10 microcoulomb. Let me divide this by 10 micro, and at the other end, so this is 100 microcoulomb. Let me divide this also by 10 micro. So this turns out to be 1 coulomb and this turns out to be 10 coulombs. So this is q and this is n into q. So the value of n is 10. So the value of n is 10. So here d is equal to 6 and n is equal to 10. So now you substitute this value here, 6 divided by square root of 10 plus 1. So this turns out to be 1.44. So at a distance of x is equal to 1.44 from the smallest charge, there will be no force experienced. So that would be your null point. So let me take this at a distance of 1.44 from the smallest charge, it is experiencing no charge. So this is your null point. So this is your null point. So this is the case when both the charges are similar, is for like charges. So the null point will be present at a distance of d divided by square root of n plus 1 from the smallest charge. So this is the smallest charge at a distance of d divided by square root of n plus 1. So this is your null point. So if you keep this charge anywhere other than this position, it experiences force. Look over here. Here it is experiencing force. Here it is experiencing force. Everywhere it is experiencing some amount of repulsive force. Only at this point, it is at 1.44, it is not experiencing any force, that is null point. So the other thing which you need to remember is whenever the two charges are like charges, the null point will always exist between the line joining 2-point charges, that is in between these two. Okay. Now let us consider the other case. So now let us consider unlike charges, that is one charge is positive and other charge is negative. Let me consider the point charge C as negative. Look over here. I made this as minus 100. So if I made this as minus 100, the moment I make it as minus 100, so the null point will never exist between the 2-point charges. It will be existing outside the line joining 2-point charges, that is outside this two charges and nearest to the smallest point charge at a distance of, so you already know this, a distance of, for unlike charges, so it will be existing at a distance of x is equal to d divided by square root of n minus 1 from the smallest charge. So the value of d is again 6. So I take a minus 100 microcoulombs. So n would be 10 itself. So n is equal to 10. So square root of 10 minus 1. So when you calculate this, the value turns out to be 2.77. So this indicates that at x is equal to 2.77 from the smallest charge, away from the two charges joining line, there will be a null point. So what does it indicate? So from the smallest charge at a distance of 2.77, so this is your null point. So this would be your null point. So this is 2. From here to here it is 2. This is 6. This is 4. From here to here it is 2. From here to here it is 0.7. So this is the null point when the unlike charges. So it is very important. At least there will be one question from this. You just need to remember these two formulas. That is x is equal to d by square root of n plus 1 for like charges, and it will be lying between the line joining 2 point charges and nearest to the smallest charge. And for unlike charges, at a distance of x is equal to d by square root of n minus 1 outside the line joining 2 point charges nearest to the small charge. Okay, so if I try to keep this anywhere around, okay, if I try to keep this anywhere around, so look over here, it is experiencing force. It is experiencing force. So what kind of force? It is experiencing attractive force here. Look over here, it is experiencing attractive force because this is negative charge and this is positive charge. So this line which is pointing inwards exhibit the attractive force, whereas if you come over here, so that it is pointing, arrow is pointing outwards, it is exhibiting repulsive force because this is positive charge and this is positive charge. So where will you find the null point? Exactly at 2.77. So that we have calculated using this formula. I hope you have understood the concept of null point very clearly. Okay, thank you for watching the video. I hope you have understood the concept. So to know whether you have understood the concepts better, you need to answer the quiz. The link for the quiz is given in the description below. After answering the quiz, you will be getting the result. So retake the quiz until you find that you have answered all the answers correctly and got the complete out of out results.